Hi, students. It is Tuesday, February 7th, I guess. And this is the week 6 preview. This has come out a little late. Didn't get a chance to make it this weekend. And anyway, no excuses. I just didn't do it. This is going to be a preview of lessons 10 and 11, but it's also going to be a little bit about lesson 9 because I didn't want to overwhelm you with the preview last week, talking about both the test and about lesson 9. So I kind of let you struggle through lesson 9 a little bit on your own. So I apologize for that, but I didn't want to make it way too long. So now this is the part of the class where we start getting really heavily involved in what is called hypothesis testing. And frankly, that's what we're going to be doing the rest of the semester. In lesson 9 and 10, we talk about hypothesis testing when you have one sample. That doesn't mean a sample of size 1. It means one sample. Could be any size. And when you know sigma. And in that case, we've already done some of that, even though we haven't really called it hypothesis testing yet. We've done some of that because that's where you calculate the z-score, and then you figure out the probability of the z-score. But we've got a few extra things coming up with hypothesis testing. So I want to, and these are pretty well defined in lesson 9, but I want to talk about those just a little bit more. Now, one of the things that's important to know, so I've got a master's degree in statistics, but I had to hear this hypothesis testing, type 1, type 2 errors, alpha, beta, null and alternative hypothesis, p-value, significance level. I had to hear all this stuff combined probably 20, 25, maybe even 30 times before it started to resonate with me a little bit. So if it doesn't make perfect sense to you after the first reading, don't sweat it. You are not alone. We're going to be doing plenty of this for the rest of the semester. Okay, lessons 9 and 10. Like I said, this is one sample, sigma known. In other words, the sigma of the population, the standard deviation of the population, is explicitly given to you in the story problem that's given. Okay, hypothesis. You have two hypotheses. One is called the null hypothesis. That's N-U-L-L, null hypothesis. And that's symbolized by an H with a subscript of an O. So it's H naught or H null, the null hypothesis. The null hypothesis always, 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 always contains the equal sign. Even if you're trying to disprove something, even if you've got you've invented a new shoe that you think lasts longer than the typical shoe, the way you will approach it is you'll say, hey, old shoe and new shoe, they're equal. They will wear equally. You might want to try and disprove that, and that might be your whole point in running a hypothesis test. But you set up the null hypothesis that everything is equal, everything's the same, nothing's changed, and then you try to use data, try to collect data to disprove the null hypothesis. Okay, so that's one thing. The alternative hypothesis takes one of three forms. The alternative hypothesis is H sub A. That's how you write it. That's how you'll see it written. And it will take three forms. One of the forms is H. So let's say your null hypothesis is mu is equal to 400. The alternative hypotheses will either be mu is not equal to 400. That's a two-sided test. Or mu is greater than 400. That's a one-sided test. Or mu is less than 400. That's also a one-sided test. So the cool thing about the alternative hypothesis is it gives you a clue as to whether your test is a one-sided or a two-sided test, and that helps you solve the problem later on. Okay, what else I want to tell you about null hypothesis? If the p-value is low, reject the null. If that's not written on your cheat sheet yet, please write it on there. If the p-value is low, reject the null. How low does it have to be? It has to be less than alpha. What is alpha? Well, as the experimenter, you get to choose it. Typically, most of the time for this class, alpha will just be 0.05. And it's been that way forever. Most of the reason is because before computers and calculators, statisticians had to use tables to calculate their test statistics and to calculate the probabilities, the p-values. And the reality is you didn't really calculate your p-value. You just found out if your critical value, if your p-value was less than the critical value. And that's a little bit beyond the scope of what we're trying to do here. But anyway, that's why alpha is usually 0.05. It can be other things, but it's usually 0.05. What does alpha mean? Alpha is the significance level of my test. So what does that mean? Well, alpha is also how willing I am to commit a type 1 error. So it's getting kind of convoluted now. Let's talk about some of these things. By the way, I'm going to send you a link to a mini lesson I made a couple years ago that talks about alpha, beta, true null hypotheses, false null hypotheses, things like that. And so it's kind of a mnemonic device to help you kind of straighten that out in your mind. Okay, type 1 error is when the null hypothesis is true, but I reject it anyway. If the null hypothesis is true and I don't reject it, then that's not an error at all. That's the correct thing to do. If the null hypothesis is true, but I reject it, that's an error, and that's a type 1 error. On the other hand, if the null hypothesis is false, but I accept it, and I'm putting that in air quotes because we don't ever really accept the null hypothesis, but if the null hypothesis is false and I fail to reject it, which is the kind of sort of the same thing as accepting it, that's a type 2 error. Okay, why do we not accept the null hypothesis? Well, there are lots of statistical reasons we don't do that are way beyond the scope of this class. But let me give you an example of a jury trial. So if you're accused of a crime, in America anyway, we are presumed innocent until we can be proven guilty. So, and if I'm accused of a crime, maybe I'm accused of theft. Okay, the null hypothesis is Mike did not commit the crime. Mike did not steal anything. If the prosecution presents enough evidence to convince a jury that in fact I did steal something, then the null hypothesis, which is Mike didn't commit the crime, will be rejected in favor of the alternative hypothesis, which is he did in fact commit the crime. If for some reason the prosecution has a weak case and they can't get enough evidence together to convince the jury that I didn't commit the crime, to convince the jury that I did commit the crime, I would probably be found not guilty. I'm not found innocent. That means they failed to convict me. I may very well have committed the crime, but there just isn't enough evidence to convince you otherwise. So, in the same way we do it in a jury trial in the U.S. is the same way we do null hypothesis. You either reject the null hypothesis or you fail to reject the null hypothesis. We don't ever accept the null hypothesis. So once again, if the p-value is low, reject the null. If the p-value is not low, if the p-value is high, then we fail to reject the null hypothesis. You probably ought to write that down somewhere. What else do I want to tell you? There's going to be several questions the rest of the semester about sufficient evidence. So these can be kind of convoluted in the way they're worded and you can't figure out what's going on. There's a way to break them down. The way to break them down is to think of the questions in terms of null and alternative hypotheses. But if you have a low p-value, that means you have sufficient evidence to reject the null or sufficient evidence to accept the alternative. If your p-value is high, you have insufficient evidence to reject the null or insufficient evidence to accept the alternative. So as you're reading those, read through them very carefully and closely and see what you can figure out. All right, what else I want to tell you? Okay, so lessons 9 and 10 are one sample sigma known. Lesson 10 starts to talk about confidence intervals. There's another mini lesson I'm going to send you this week because confidence levels can take on a variety of different ways of wording them. And this, again, is another question you're going to see many, many, many times this semester. So I put together a mini lesson that kind of talks about several different ways that people will try to describe what a confidence interval is. And there are some that are correct and some that are incorrect. So I very clearly tell you which ones are correct and which ones are incorrect. Okay, then lesson 11, we get into this thing where we're doing one sample hypothesis testing, but this time sigma is not known. The population standard deviation is not known. So we have to use the sample standard deviation, which is S, and we use that to kind of estimate what the population standard deviation is. The bottom line is this. If sigma is known, I'm going to use a z-test. I'm going to calculate a z-score, and I'm going to use the applet to figure out what my p-value is. But if sigma is not known, it is no longer a z-score or a z-test. It becomes what's called a t-test. Maybe you've seen that already, maybe you haven't. But it's similar to a normal distribution, but it's a little bit different. We actually, I think there's a link to an applet for the t-test, but SPSS will spit out the values of the t-distribution for you also. So make sure that those are clear in your mind, because right now here's what's going on. Okay, we talk about sigma known, so it's a z-test, and then we give you all a bunch of problems on the z-test. And then we go to a new lesson where we talk about sigma unknown, so it's a t-test, and we give you a whole bunch of questions about a t-test. Next week, we're going to start talking about two samples. There's two different cases of two samples. One where they're independent samples, the samples are independent of each other, and the other where the samples are dependent or paired, and you'll find out the difference about those next week. But as you can imagine, as we go through the semester, we're going to talk about a total of 8 different kinds of scenarios where we'll be collecting data and running a test. Fair warning, pretty soon, one of the questions that's going to pop up is going to say, hey, we just studied about 2-sample paired in this lesson, so here's a bunch of 2-sample paired problems. The text is actually going to give you a problem and say, here's the situation, here's the scenario. What sort of a test should the researcher be running on this? The first few times you do that, you're going to think, wow, this is pretty hard. And it is kind of difficult. There's a way to get through it and a way to solve those, and I'll get to that in a week or two, because I've got a handout I can give you to help you practice. But the bottom line is this. The only way to get very good at stuff like that is to practice a lot, so I've created a lot of opportunities for your practice. They're not required, but if you want extra practice, you can use them. And the second thing is to very methodically go through a list of questions that help you figure out what's going on. We'll get to that later. Okay, so that's it for this week. Like I say, I'm going to give you links to 2 other videos. They're not required, but I would highly, highly recommend you at least take a peek at them and see kind of what's going on, because I think they'll be very helpful to you. All right, if you have questions, want to go over something, want to go over a test, or any of that stuff, let me know, and we'll schedule some time and we'll go over it. I know that some of you are thinking, well, why can't I see my test? That's a department policy. It's not my policy, but you will not be able to see it. So if you want to review what happened on that, the only way to do that is to get with me. Okay, have a great week, and let me know if you have any questions. Thanks, bye.